Hello friends, grab your coffee, grab your cookie, and today, keep both far away from any grinding machines because we are talking about nickel dust. Yes, the dust that looks like ordinary gray powder, but is actually toxic, conductive, reactive, and regulated under OSHA, NFPA, and multiple health exposure limits. My name is Michael Klepik, and for 15 years I have been designing filtration and dust collection systems for metalworking plants, battery production, alloy manufacturing, powder metallurgy, and nickel refinement facilities. Let me explain why nickel dust demands extremely high safety standards. What nickel dust really is. Technical description. Nickel dust forms when nickel or nickel alloys are cut, ground, polished, drilled, filed, or processed in powder metallurgy lines. Technically, first, particle sizes range from 1 micron to 100 microns. Second, the most respirable and dangerous fraction is from 1 micron to 10 microns. Third, bulk density ranges from 5,000 to 8,000 kilograms per cubic meter. Fourth, dust often contains nickel metal, nickel oxide, nickel sulfate, or alloying elements like chromium or iron. Fifth, nickel dust is electrically conductive and easily spreads through equipment. Nickel dust is a combination of toxic heavy metal particulate and reactive metallic powder. Where nickel dust is common in industry. Nickel dust appears in, first, grinding and polishing of stainless steel and nickel alloys. Second, battery manufacturing, especially for NMC and nickel-based cathodes. Third, welding or cutting of nickel-based superalloys. Fourth, powder metallurgy and sintered metal production. Fifth, refining, scrap recycling, and catalyst production. Sixth, electroplating and surface coating lines. Wherever nickel is shaped or processed, dust appears. Why nickel dust is dangerous? Health plus physical hazards. Nickel dust presents two categories of hazards. Health hazards first. Nickel is classified as a carcinogen. Second, dust inhalation causes asthma, chronic lung disease, and sensitization. Third, nickel oxide is even more hazardous to lungs. Fourth, skin contact can cause allergic reactions and dermatitis. Fifth, OSHA sets a permissible exposure limit of 1 milligram per cubic meter. Physical hazards. First, fine nickel dust can ignite under NFPA 484 metal dust conditions. Second, conductive dust can short out electrical components. Third, oxidized nickel dust can heat up under certain conditions. Fourth, dust layers create a secondary deflagration risk. Fifth, nickel dust is abrasive and corrodes sensitive surfaces. This dust is both poisonous and reactive, a dangerous combination. Combustibility of nickel dust, NFPA 484. Nickel dust is less explosive than magnesium or aluminum, but still regulated by NFPA 484 because first, particles below 50 microns are reactive and can ignite. Second, alloy composition changes combustion behavior. Third, nickel powder contaminated with oils ignites faster. Fourth, hot grinding sparks can ignite airborne nickel dust clouds. Fifth, dust accumulation increases the probability of secondary explosions. If it is fine, airborne, and metallic, it must follow NFPA 484. Behavior of nickel dust and airflow. From an engineering perspective, first, nickel dust is heavy and settles fast in low-velocity ducts. Second, fine nickel particles behave like metallic smoke. Third, conductive particles cling to steel ducts and motors. Fourth, nickel oxide embeds deeply into filter media. Fifth, dust corrodes certain metals when humidity is high. For nickel dust, I designed duct velocities from 4,500 to 6,000 feet per minute. Filtration equipment that works best, Baghouse cartridge collector. Best for fine respirable nickel dust. First, high-efficiency membrane-coated cartridges capture ultrafine particles. Second, conductive filter media reduce static charge. Third, strong pulse cleaning handles dense nickel oxide. Baghouse Blizzard used when dust loads are heavy. First, rugged bags tolerate abrasive nickel particles. Second, large chambers maintain consistent airflow. Third, pre-separation zones reduce filter wear. System requirements. Nickel dust requires first, conductive ducting only, no plastic ducts. Second, abrasion-resistant elbows and inlets. Third, anti-static filter media. OSHA and NFPA compliance requirements. OSHA nickel dust is regulated by multiple OSHA rules. First, the permissible exposure limit is 1 milligram per cubic meter. Second, employers must conduct a dust hazard analysis. Third, respiratory protection is required when limits are exceeded. Fourth, hazard communication and nickel-specific training are mandatory. NFPA 484, combustible metals. NFPA requires, first, explosion vents for applicable dust collectors. Second, isolation valves on inlet ducts. Third, anti-static media and bonding of all equipment. Fourth, no plastic ducting for conductive metal dust. Fifth, elimination of nearby ignition sources. Compliance is essential for safety and required for insurance. Capture hood design for nickel dust operations, updated 7 items. Because nickel is both hazardous and valuable, capture must be extremely efficient and engineered for minimal escape. I design, first, fully enclosed grinding and polishing hoods to prevent nickel dust from escaping during aggressive abrasion. Second, high static extraction arms positioned close to manual finishing and trimming points. Third, downdraft tables for surface prep, grinding, and electrode cleaning where dust naturally falls downward. Fourth, tight sealed capture at battery electrode mixing and coating stations where fine nickel particulates become airborne easily. Fifth, multi-point extraction along powder metallurgy lines, especially at blending, screening, and die filling positions. Sixth, enclosed CNC or machining area hoods that remove nickel particulate immediately at the cutting interface. Seventh, capture in refining and recycling operations, especially where nickel scrap is shredded, milled, or reprocessed. Efficient capture keeps toxic and conductive nickel dust out of both the breathing zone and the ductwork. Nickel dust may look harmless, but it is one of the most hazardous fine metal dusts used in modern industry. It is toxic, conductive, abrasive, partially combustible under NFPA 484, and strictly regulated by OSHA. With strong airflow, conductive ducting, high-efficiency filtration, and full compliance with safety standards, we can control nickel dust safely and reliably. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, nickel belongs in your alloys, not floating in your breathing zone. See you in the next video.